Assalamu alaikum. My name is Redwan Rahman. Today I'll be presenting process synchronization. Process synchronization is a way to coordinate the execution of processes that share resources to avoid conflicts and ensure data consistency. It's essential for multitasking systems prevent race conditions, especially when multiple processes access shared data. For analogy, imagine two people trying to withdraw money from the same bank account. Without coordination, this could lead to incorrect balances. So the challenges are race conditions. These conditions occur when multiple processes attempt to read or write shared data at the same time. The outcome depends on the timing of the process, which can lead to incorrect and unpredictable results. For example, if two processes update a variable concurrently, like the previous analogy, the final value might be inconsistent. The next one, data inconsistencies. So we saw in the bank example, when we multiple process modify shared data without synchronization, it can lead to invalid system states. Deadlock. This occurs when two or more processes wait infinitely for each other to release resources. Starvation. A situation where process waits indefinitely to access a resource because other higher priority processes are continuously favored. Priority inversion. A lower priority process follows a resource needed by a higher priority process, causing delays in execution. Next, I'll be talking about the structure of a process and synchronization requirements. With mutual extinction, only one process can access the shared resource at a time. Process guarantee. If no process is critical section and some process want to enter their critical section, only those processes are not in their remainder section can participate in deciding which will enter its section next. Third is bounded waiting. Bounded waiting is a bound must exist when the amount of time that process is allowed to wait to enter the critical section. Critical section problems are the fundamental challenges like control access, coordination, and data integrity. The critical section problems involve coordinating the access to the shared resources. Challenges arise in the coordinating multiple processes. There is a need for controlled, predictable access patterns in computing. This ensures data integrity. Software solution to synchronization. Peterson's algorithm is a classic solution to two processes. It uses two shared variables, flag, to show the intent to enter and turn to decide whose turn it is. It ensures mutual exclusion but involves busy waiting and only supports two processes. This follows the hierarchy of process, mutual exclusion, and the two shared variables, turn and flag. And the third is algorithm. Hardware level synchronization mechanism. The modern CPUs provide atomic operation instructions that complete in one step and cannot be interrupted. There are 2 points. Test and set returns the old value of lock and sets it to true. A process only enters the critical section if the lock was false. Compare and swap. Compares a memory value to an expected value and swaps if they match. Useful for lock implementation. Synchronization tools in operating system. We'll be talking about three synchronization tools: mutex locks, semaphores, and monitors. The mutex locks binary locks that prevent process from entering the critical section simultaneously. Mutex require acquire and release methods that can lead to spin lock behavior under heavy loads. Semaphores. Semaphores are introduced by Diastra. Semaphores are integer-based counter with atomic weight and signal operations. There are 3 steps for semaphores and monitor higher level abstraction combining data and operations. It condition values weight and signal to handle complex synchronization. There are three classical synchronization problem: the dining philosopher problem, producer consumer problem, and reader writer problem. Synchronization support in real operating system. Different operating systems perform various built-in synchronization mechanics. For example, Solaris, adaptive mutex, and priority inheritance. Linux uses semaphores, spin locks, and others. And Windows, the most common operating system, it uses critical sections, mutex, semaphores, and events. So the process synchronization is crucial for computing and affecting synchronization, and it ensures data consistency. System reliability and hardware and software solutions must be carefully chosen. Thank you for your attention.